Welcome back to our video module on quantum mechanics. As we covered earlier, we looked at mean and standard deviation in orange, and we saw how to understand expectation value for both discrete and continuous distributions. Today, we're going to look at the idea of probability. So let's start by taking a look at here. I'd like to know, what is the probability that some students got, a 60? X equals 6. Now we know that there's 3 students. We know there are 3 students who got 6s, 10 students overall. So we do 3 over 10, which means we take the number of students that are in our chosen area and we divide it by the total. Likewise, if we were to take a look at our continuous probability distribution, we'd say, what is the probability that somebody got between an A and a B? Whatever that is. Well, we'd find first the area under this curve, and then we divide it by the area under the entire curve. Now, one of the shortcuts that we often take is we define rho of x as if the area underneath the curve equals 1. So if we say that the integral from negative infinity to positive infinity of rho of x dx equals 1. We call that curve normalized, and down here what we'd have a simplification where the probability that something is between a and b is simply the integral of rho of x dx from a to b. And in fact, this idea is really useful to be able to what we would say normalize our solutions. So let's take a look at how that would happen. And in fact, this is such a useful tool to be able to normalize something, to make sure that the area under the curve is 1, that it's worth noting here how to do it, where we simply say that rho n, which is the normalized rho, equals rho un, which is the unnormalized rho un, divided by the integral of rho un dx. And in this case, we're simply taking the function, dividing it by the total value of the function, which will leave the area under this entire curve at 1. And this is the idea of normalization. So in summary, we can use our probability to identify the chances of getting specific values, and by normalizing the curve, we're able to simplify our equations in such a way so that we often don't have to worry about this denominator. This will become important later on. Thank you for joining me for this short video module on probability and normalization. I look forward to seeing you in our next video as we see how this relates to quantum mechanics. I'll see you then.